Shandy mama, ahead. He ahead.
Batu bebura kumana. Awana liboya. Bulaya na lima. Kuli senchame.
Vela ubule.
Ene muchaiti tolo laga.
Gane tu wabile.
Kuli senchame.
Vara ubule.
Ene muchaiti tolo laga.
Gane tu wabile.
Itori chapela vele.
Garu ya wile.
One day itori chapela vele.
Baru ya wile.
Itori chapela vele.
Garu ya wile.
Itori chapela vele.
Garu ya wile.
One day itori chapela vele.
Shandy mama, ahead. He ahead. He ahead. Sipiri kuranya garu kumisari dokuma. Au kanana koya wise galelo wise boy. Dintori to aya chaleni rata na burina rasaipa. Ritena au kanana koya ubuya la murab. Okay, jarirele bakala ore du petruile. Manavari tobuile. Dilo kamuka dilukile. Ditori chapela belle. Ditori chapela belle.
Kuli senchame.
Vela ubule.
Ene muchaiti tolo laga.
Gane tu wabile.
Kuli senchame.
Vara ubule.
Ene muchaiti tolo laga.
Gane tu wabile.
Itori chapela vele.
Garu ya
One day
wile.
itori chapela vele.
Baru ya wile.
Itori chapela vele.
Garu ya wile.
Itori chapela vele.
Garu ya wile. Ditori chapela belle. Na leo ditori chapela belle.
Kuli senchame.
Ditori chapela belle. Na leo ditori chapela belle.
Senagabe senalia. Senagabe senali. Erito shapa bele rilo rapela godes. Tabele borina mole passing richuna imes. Pelo gasi witi. Kano regeto, kano kumana kapfane ke trenda. Bari kutute tenda. Ene ke sauzari tenda. Ay muhimam bless, adira me tola romela ni paper. Peke zakabaga siri chibi. Siri tepa men we believe. Mana baba bone di fili. Malume na ligiri series. Kiba babi se di pilis. Ulaya na lima. Tori chapela vele.
Ditori chapela belle. Na leo ditori chapela belle.
Kuli senchame.
Ditori chapela belle. Na leo ditori chapela belle.
Ito chapa vele. Kuli senchame.
Vela ubule.
Ene muchaiti tolo laga.
Gane tu wabile.
Kuli senchame.
Vara ubule.
Ene muchaiti tolo laga.
Gane tu wabile.
Itori chapela vele.
Garu ya
One day
wile.
itori chapela vele.
Baru ya wile.
Itori chapela vele.
Garu ya wile.
Itori chapela vele.
Garu ya
One day
wile.
itori chapela vele. Bulaya na lima.
Right. So think of this thing like a juice machine, right? Let's say think of like a juice machine. So like this is a machine, right? So if you put, let's say we put three, there, it is gonna multiply it by, let's say it's gonna multiply it by 2, right? And then you're gonna get there, you're gonna get 6, right? So this is the function, this is the input. If we put an input, and then this is the output, right? So we can represent this by f of x is equals to 3 of x, right? Now the inverse here, the inverse here will be, if your answer is 6, if your answer here is 6, right? What did you put in, right? So that you can, what did you put in? If your answer is 6, we want to know the input. What did you put in, right? So the inverse is the direct opposite of this one, right? What did you put in? If your answer is what? It's 6, right? So that's gonna give us a inverse is gonna be this one, equals to x over 3, right? Over 3. So for a function to be an inverse, to be an inverse, it have to be 1:1, right? To be 1:1, right? This 1:1 is the one that that we use to test a vertical line test, that we use, like a vertical line test that we use to test if something is a function or not, right? Right. So an inverse also is like a mirror. An inverse is like a mirror, right? It's like a mirror image. If you actually draw if you actually draw a function, if you actually draw a function, right? So let's say this one is the, okay, let's say this one is the function of of is the function of, it's an exponential function. Initial function, the inverse will be, say it's gonna be something like this, right? So inverse is like it's like a mirror. If you, it's like a mirror of a direction. If you draw a function and fold it, you should draw a function and fold it, right? So how do we actually check in that this function is the inverse of the other, right? How do we check that this function is actually an inverse of the other? So for the function to be an inverse of one another, for the function, it's too bright. Function to be inverse of one another, of one another, they need to be able to undo each other, right? They need to be able to undo each other, right? So for f of g of x is equals to x, right? For all x, right? And then the other one, g f of x is equals to x, right? So they need to be able to undo each other. So then that means we'll be able to say that these functions, they are actually inverses of each other, right? So let's also talk about exponential function. So an exponential function is exponential function is it's denoted by f of x is equals to a to the power of x, right? And then a have to be greater than what? Have to be greater than 0, right? Have to be greater than 0. So remember that for an exponential function, f of x is equals to a to the power of x, and then a have to be greater than what? Than 0, right? So this x is actually a what? That's the exponent, right? So, and then we also have the power function, right? We also have the power function where f of x is equals to x to the power of n, but this one is actually the base, right? X is the base, right? So we have two graphs, actually not two. A to the power of x. This one is a to the power of x. We're gonna draw it like this. It's gonna increase, right? It's gonna increase only if a is greater than 1, right? And then this one is going to be a decaying graph, right? And then if a is somewhere there, right, between 0 and 1, right, it's gonna decrease, right? But if a is greater than if a is greater than 1, then it's gonna what is going to increase, right? So let's make example of that. Let's make example and see how our graphs is going to actually look like. Look an example and see how our graph is actually going to look like, right? So there let's have a graph. Let's do a graph of f of x equals to 2 to the power of x, right? Immediately, because I see that 2 2, which is that's my a, and I said that my a is actually greater than 1, right? This automatically means that there's gonna be growth, and then that my graph actually grow. My graph is going to go up, right? To go up very fast. My graph is going to go up very fast, right? So so 2 to the power of x. Let's try Okay, y equals to 2 to the power of x. When x is equals to 0, y is going to be equals to 1, right? 0 and 1, right? And then if x there is going to be equals to 1, y is equals to 2, right? Then we're going to have 1 and 2, right? So let's have only 2 points, right? We're going to have 0 and 1. 0 and 1 is going to be there. 0 and 1 is going to be there. And then we're going to be 2 and 1 and 2. Right, and then my graph is gonna go up very much steady. It's gonna grow very much. All right, and then we can also look and if our f of x is gonna be 1 over 2 to the power of x. All right, and then I'm gonna have what if my x is equals to 0, 1 over 2. My x is equals to 0. That means my 1 is going to be equals to 1. I'm gonna have 1. Gonna be 0 for x and 1, right? And then what if it's equals to 1 there? Then I'm gonna have 1 over 2 and 1, right? So let's see what's going to happen. I'm gonna throw it at the same place, right? I'm gonna be having 0 and 1, which is gonna be there. And then I'm gonna have 1 and 1 over 2, right? 1 over 2 and 1. Then 1 over 2 did actually calculate it right. Like I said, I'm gonna have plus 1 there. I'm gonna have 1 over 2 for y, for 2 and 1, right? So I'm gonna have 1 there, and then for it's gonna be it's gonna be somewhere there. Right? So my graph is gonna go something like this. Right? Supposedly, let's say this graph is gonna be g of, or it's of g of x. So this one is gonna be g of x, and then that one is gonna be of f of x. Right? So we also have something like a special number. Something like a special number. We have a special number that we call natural exponential function, right? We have what we call a natural exponential function. We have what we call the natural exponential function. Natural exponential function. So what I can say about this one is that it's a very special number, right? It's a very special number in mathematics. Special number, right? And then this natural special number f of x is equals to e of x, right? So this x that special number is e, right? So this number is equivalent to 2,7182 2, 8, 1, 8 to 8. Right? So this number, it passes through 0 and 1. Passes through 0 and 1. It's very fast and big. Just get faster and bigger. Fast and bigger. So remember that we can also write this number as e to the power of x is equals to x exponent x, right? And then we have to also further note that e to the power of 0 is equals to 1, right? So there's something very much important is that this number, in number e, is the number so that the gradient of the curve at point where x is equals to 0, the gradient is equals to 1, right? Where x is equals to 0, the gradient is 1. The gradient or the slope where x equals to 0, this place is equals to 1, right? It's very much important. So we have got properties. We've got properties of exponential functions. Right? There we know them that we have a is the power of y. A power of is equals to a x plus y. We add, if we're multiplying the base that are the same, we add the numerator, the base that are the same, we add the exponent, right? And then when we have a to the power of x over a to the power of y equals to a to the power of x minus y, right? We subtract the exponent, right? And then when we have a to the power of x multiplied to the 1, we have got a to the power of x times y, right? And if we have ab, the power of x equals to a to the power of x, b to the power of x, right? And then if we got e to the power of x, e to the power of y, we have got e to the power of x plus y, right? And then if we have got e to the power of x over e to the power of y, we're gonna have e to the power of x minus y, right? And if we have got e to the power of x of y, we're gonna have got e to the power of xy, right? Then if we've got e to the power of x 2, we're gonna have e to the power of 2x, which is equals to e to the power of x, e to the power of x, right? Because we know that they are actually like two exponents. Right. Yeah, that's all about exponential functions.